Hi, welcome to Algebra 2, Lesson 2-5, Completing the Square. In this lesson, we'll be able to solve quadratic equations by completing the square. The vocabulary that's important in this unit would be completing the square. What does it mean by completing the square? We'll see. Let's start with critique and explain. Hannah and Enrique use different methods to solve the equation x squared minus 6x plus 9 equals 16. Let's see. So they start with the same equation, right? And let's look at their steps. Hannah does something. It seems like she is subtracting 16 on both sides, right? And so minus 16 here, and then minus 16 on this side. And she got negative 7 here. And that looks right. And she factored out, and she has x minus 7, x plus 1 equals 0. So she's solving them for zeros. So solutions are 7 and negative 1. Enrique has factored it out before she solved for 0. And then she set the equation equal to x minus 3 equals 4 or x minus 3 equals negative 4 because x minus 3 is squared, it would either be it could either be negative 4 or positive 4 to get positive 16, right? Because it's squared. So she also has set up two different equations, but it's not set up to 0. And she still gets the same answer, 7 and negative 1. So let's think about this. Does Hannah's method work? Yeah, we looked at it, and we've been using this method ever since, right? If her method is valid, explain the reasoning she used. If her method is not valid, explain why not. So how can we validate her work? She used the properties of equations, right? Equalities. She rearranged the equation and then factored the resulting quadratic equation to determine the solutions. So it's fine. So yes, her method works. And then we need to explain. I'm gonna move it here, okay? So yes, Hannah rearranged the equation using the property of equalities, and then factored the resulting quadratic equation to determine the solutions. Okay. Part B, does Enrique's method work? We looked at hers too, or his work too, and it works too because he has the same answer, right? If his method is valid, explain the reasoning he used. If his method is not valid, explain why not. He first factored even before solving for 0, and then so that the factors on the left side on the equation were the same. So he's not doing anything crazy. He's still keeping in mind the properties of equalities, right? Yeah, and then he took the square root of both sides of the equation to determine the solutions, and the solutions are the same as Hannah's. And it's valid because he didn't change the equation. It's still equal to each other, and it makes sense that x minus 3 is a number that's squared to make a positive 16. So it must be either 4 or negative 4. And so x must be 7 or negative 1. Yeah, so it makes sense. Where should I put B? I'm gonna make this smaller so that I can put b over here. So let's write the answer for b. Yes, he first factored and saw that the factors on the square root of both sides of the equation to determine the solutions. Okay, so let's look at part C. Can you use either Hannah's or Enrique's method to solve the equation x squared plus 10x plus 25 equals 3? Yeah, explain why. You can't just say they have the same solution and that's why. No, why? Why can we use either of them? Because both of them don't change the equation, right? They use the properties of an equation, and they don't. They all make sense. It's not like they broke the rules or anything, right? So yeah, you can factor it first, or you can solve for 0 and then factor it and then solve. It's just a matter of the order. Are you doing this first or that first? And does it really matter in this case? Not really, right? So whatever you prefer would be fine. But for this equation, actually, we're looking at a different equation. X squared minus 6x plus 9 equals 16. It's different than the new one, right? So if you look at the new equation, what's the problem? What would be the problem for this one? If we use Hannah's method, we have x squared plus 10x, and then we subtract 3 on both sides, and then we have 22 equals 0. And then you factor each side, but it's hard to factor, right? It's hard to find the you have to find the perfect square anyway. So actually, Enrique's method would be the easiest, because if you use Hannah's method, you're going to have an irrational solution. And so if you use Enrique's method, it'll be easier to figure that solution out, because you can factor this first, and then you can set up an equation to solve for it. So it makes it easier. Does that make sense? So let's go ahead and explain that in words, and then we'll explore that in the examples later. Okay, so either method would still work, but Enrique's method would be better. So let's say that you can use Enrique's method because you can factor the left side of the equation, and because the factors are the same, you can take the square root of both sides, right? And we're not done. We also want to add that because the equation where should I add? Because the equation has an irrational solution, you cannot use Hannah's method of factoring. Okay, so sometimes Sometimes Hannah's method doesn't always work. So in that case, we want to use Enrique's method. So the essential question now is how could we solve a quadratic equation by completing a square? Because that would be another skill that would be really helpful for solving problems like this. So we'll continue with the first example in the next video.